Okay, everyone. So here's Notes 2.5 Cool Edition. And I have everything already filled out. So just follow along, make sure you're paying attention so you just understand where everything is coming from. So it says Calcurama had a net income of $5 million in 2010, while a small competing company, ComputerFest, had a net income of $2 million. So in my table, where it says 5 million, and in Calcurama's table, I'm going to write 5 million. I'm not going to write all the zeros because I'm lazy, so I'm just going to write 5 mil. Same with the $2 million. That is the start for ComputerFest at time zero. They are starting out with that much money in 2010. Okay, so ComputerFest, 20 million. The management of Calcurama develops a business plan for future growth that projects an increase in the net income of $0.5 million per year. This increase means that we are going to add by $0.5 million. We do not multiply this. This is not a percent. If it says increase with a decimal, we add. So that means we have 5.5 mil at year 1. At year 2, we have 6 million. At year 3, we have 6.5 million. At year 4, we have 7 million. And then time 10, year 10 on your paper, wait, we're not going to get to that yet. Then it says, while the management of ComputerFest develops a plan aimed at increasing its net income by 15%. So here we got a percentage. We have a percent increase. So we have to take 100% of our original number and add on 15%. That's what a percent increase means. When I do 100 plus 15, I get 115%. But I can't multiply percents down my table. I have to change it to a decimal. And when I do that, I move it over 2 to the left, and I get 1.15. And that is what we multiply down our table. Anytime you see a percent means we multiply every single time. Okay? So when I do the math, 2 times 1.15 is 2.3. 2.3 times 1.15 is 2.65 and something else. I'm going to abbreviate because I only want to do 2 decimals because, again, Miss Rowolf is lazy. Then I multiply by 1.5 again, and we get 3.04 million. And then we get 3.5 million when we multiply by 1.15 again. Now, what we're going to do is we're going to write equations, right? We're going to write the explicit equation. Now, this first one I have written here is what I want you to start writing by. So what we do down the table is add by 0.5 million for Calcurama. Okay, that gets the X attached to it because that is what we are doing down our table. Whatever you do down your table gets the X. Okay, and it's just an X because we started at time 0. Then we started with $5 million, so we say plus 5. Now, if you write it the old arithmetic way that we did for a really long time, that's fine. They mean the same thing, okay? But just know that these two equations are equivalent or equal to each other. So when we figure out 10 years, we plug that in for our X, okay? Because it represents X in our X table, part of our table. So remember, 0.15x means 0.15 times x. So that's why when I replace the x with that 10, we are still multiplying, and we represent that with parentheses. And when I do the mathy math here, I get 10 million. So at 10 years, they got 10 million. Looking at ComputerFest, the equation for that is exactly like how we did for geometric. Nothing changes, nothing flips around, nothing crazy. So we have y equals, we started with 2 million and we multiplied by by 1.15 down our table. Remember, we want to represent multiplication with a parentheses, because if you use your multiplication x here, I don't know if this means a variable or if this means multiplication. Okay, so always use your parentheses when you represent multiplication. And then we have an x in the exponent because it is an exponential and we are multiplying, and it's just an x because we started with time 0. And just like prior, this 10 represents year 10, which is x. So we're going to replace this x with a 10, and this is the math for that over here. Type this into your calculator exactly. If you weren't in class today, I will show you how to do an exponent in your calculator the next time you show up. And we get $8.09 million. So number 2 is to describe each company using our vocabulary we've been using. So Calculorama is arithmetic and linear, and it's continuous because we don't all of a sudden have $0.5 million more, right? We gradually get there throughout the year. So it's continuous. Same with ComputerFest. It's continuous because we gradually throughout the year get 15% more dollars. However, ComputerFest is exponential and geometric, and that is because we are multiplying, whereas Calculorama, we were adding. Okay? 3, you decide. Which company would you want to be the boss of? Choose. Tell me why. All right, next up, we're going to graph the table. Okay? So plot the dots of the tables we have from before. Okay, it should look something like this. This is Calculorama's line. It should be a straight line because they were linear. Okay, versus ComputerFest, which is geometric and it curves. Now see, eventually ComputerFest surpasses in money Calculorama. So if you chose Calculorama for number 3, shame on you, because ComputerFest eventually is going to have more money. So here's what's an important love note. This is the most important thing about today's lesson. Exponential always beats linear every time, no matter what. Whether if you're increasing or you're decreasing, exponential will always beat the linear. All right. Next up, they wanted to figure out the total net income for each year at year 20, which means X is 20 because X represents our years. So here's where our equation for Calculorama, plugging in that 20 for X. Here's ComputerFest equation, plugging in 20 for X. Calculorama at year 20 will have $15 million. ComputerFest will have $32.73 million. Whoop, whoop. So number 6, would you still choose the same company you chose for number 3? Why or why not? And then lastly, it says, what are the differences in how linear functions change opposed to exponential? Linear has a rate of change. The rate at which it changes from one point to the next is by adding and subtracting. Versus exponential, their rate of change, which again, rate of change is a new phrase, if I did say that before, and its change from one point into the next is by multiplying. Okay, that's what this rate of change word means. How did you get from one point to the next? Did you add to get there, or did you multiply to get there? Okay, this is a multiplication symbol. All right, there is no homework for the rest of this week because we have that test coming up. So you need to do any makeup work, and then I will see you the next time in class.